So volume, we can just take like a radius and a height and solve for the volume of a cylinder or cone, or take a radius and solve for the volume of a sphere. But some questions are actually asking more about the relationship between pieces of the same shape or two different shapes. So we're going to talk about that briefly. So on the first one here, we're saying that the radius of a cylinder is changing, but the volume is staying the same. So what would have to happen to the height to keep that volume the same? So think about this like drinking cups. Okay, so let's say, you have just kind of a standard glass, okay? But then let's say that I make the mouth of the glass bigger. Okay, now in order for these to have the same volume, the thing is that this glass would have to be much shorter in order to hold the same amount of liquid. I know that's kind of weird, but basically whatever happens to the radius, the height needs to do the opposite to kind of compensate for it so that it still stays the same amount. So you could have one glass that's kind of tall and thin, and you could have another one that's thicker, but it's really short. Okay, so if the radius increases, then the height has to do the opposite. So it would have to decrease in order for that volume to stay the same. Now, the same would also be true, okay? Or the opposite would also be true. So if I had a glass and I make the radius smaller, so I'm making it thinner, that means for these to hold the same amount, this glass is going to have to be much taller in order to hold the same amount. So if the radius were to decrease, so to get smaller, in order for it to still hold the same amount, the height would have to do the opposite and increase. So again, whatever the radius is doing, the height would have to do the opposite in order for it to still hold the same amount. All right, so on this one, it says a cylinder and cone both have a radius of 8 and a height of 3 inches, and they want to know the ratio of the volume of the cylinder compared to the cone. Okay, now there are a couple ways to do this. The most basic way, okay, is they're saying they have the same radius and the same height. That's the only reason they give you these numbers, is just to say that they both have the same radius and height. Now, if you remember in class, we did the blue water example where I actually took a cone and I filled up a cylinder. And if you remember that, it took 3 of the cones to equal 1 cylinder. All right, so their ratio is 3 to 1. Okay, now, if you actually want to use these values, you totally can. So you totally can. You can actually work them out. So if you do the cylinder, which has a radius of 8 and a height of 3. So if I actually put that into my cylinder formula, which is pi, I'm going to use 3.14 because I know that's what most of you prefer, my radius of 8 and my height of 3. Now you could actually use the pi symbol as well, which is perfectly fine. It just kind of depends on what your preference is. Either way will work. So if I do this, I'm going to get a volume of 602.88. So if I do the same thing for the cone, so it still has a radius of 8 and a height of 3. Remember, the only difference between the cone formula and the cylinder formula is the cone has this 1/3 in front. So I put the formulas up here if you needed them. So it's 1/3 pi r squared h. So if I substitute all that in, if I actually work out this piece right here, I'm actually going to get the same number, which is that 602.88. But remember, this 1/3 tells me to take a third of this. So when I do that, I'm going to get 200.96. Now, you could write your ratio like this, where you just take the two volumes, put a colon in between them, and then the other volume. That is true. Now the thing is, what I want you to see is that if I take this value, to get to this one, all I'm doing is multiplying it by 3. So this is still that same ratio of 3 to 1. that if I take this and do it 3 times, I get the same thing. Okay, so either one will work, but technically this is the best answer, 3 to 1. All right, so the last one, which is kind of tricky, okay, is that you have a cylinder that has a volume of 484 pi centimeters cubed and a height of 4 centimeters. They are asking you to find the radius of this cylinder. Now remember, the cylinder formula is V equals pi r squared h. And we are going to substitute in what we know. It says we have a volume of 484 pi. Now remember, pi is a number, so I'm going to bring it down with it. So V is 484 pi. Now since I use the pi symbol over here on the left side, when I'm looking at the right side, this pi symbol, I'm just going to bring it down. If you did not see a pi symbol in your volume, that means they used 3.14. But since I see that pi symbol, I need to make sure to use it throughout the entire problem. Now we don't know the radius, so I'm just going to bring down the r squared. But we do know our height, which is 4. Now, technically all the things on the right side here, pi, r squared, and h are all being multiplied. So what I'm going to do, to get the r squared by itself, I'm going to divide by both the pi symbol and the 4, so that these will cancel each other out. I'm going to do the same thing over here. So I'm going to divide by the pi symbol and the 4. The pi symbols will also cancel out over here. So then I'm just going to divide. 484 divided by 4 is actually 121. And then if you look at the right side, the only thing I have left is r squared. But just like Pythagorean theorem, I don't want it to be squared. So the last step here is to take the square root. So that will give me 11 for my radius. So it's saying that my radius is 11 centimeters. Now, a lot of people got unsure about these, made some mistakes. It is not a bad idea to take a second and check your work. Because some people got some answers that were way too big because they forgot to take that square root. So to check it, I'm going to use my volume formula, pi r squared h, for my volume. I'm going to substitute in my radius and the height that they gave me. So I'm using the pi symbol because my volume has the pi symbol in it. I'm going to put in my radius of 11, making sure to square it, and my height, which was 4. Well, if I square 11, I'm going to get 121. Sorry, not 12, 121. And then if I take that and I multiply it by 4, well, I happen to get 484, and just bringing down that pi symbol every single step. So you notice how I got a volume of 484 pi, which is exactly what they told me in my original problem. If I don't get that same value, then I have done something wrong. So that is a way to check your work so you can catch those easy mistakes.